Hello and welcome to the next sorting array method. And in this today video, we will talk about bubble sort. And in last video, we have covered selection sort and insertion sort. If you have any sort of query regarding both of them, you can check in the playlist below of full DSA course. In that, you can find or you can go to my channel and search for the selection and insertion sort. So before starting, I would like to tell you what is actually bubble sort. And let's move to whiteboard. Okay, so in selection sort, as you all know, we brought the smallest element to the first index. Right, we start to bring it into the first index and we iterate over the rest of the array. Right, in the bubble sort, it is exactly the opposite, in which we bring the largest element to the end and will iterate till the second last. Okay, so bubble sort is exactly the opposite. So let's talk about what is in the bubble sort. I will start with this index. Okay, and I will move till the end. If I will check whether this is greater than this or not. If this is greater than this, means this is 35 is greater than 45. No, so here no swapping will occur. Okay, and now I will increment the pointer, and now I'll check 45 is greater than 3. Yes, now I will swap and make this 45. Okay, so what we are doing each time, we are swapping and making the largest number to proceed at the last index. And as soon as we have done sorting, so here we will get 45 here, and here we will get 3. Okay, again we'll compare 45 with 24. Yes, here also swapping will occur. So here it will become 24 and here it will be 3. Sorry, 45. Here will be 45. We'll again compare 45 and 5 and we will eventually get 45. Okay, so here we are seeing that when we have iterated one time, we'll get the largest element at the last. So means in each iteration we are getting one sorted element extra. Means if I have 0 earlier sorted and I will get 1 sorted here. Again when I will again sort the array and let me see what was the value, and let me write only. We will get 35, 3, 24, 5 and 45. Now we have sorted this. This means we will get, if we have sorted one time, we will get one extra element. Means 45 is sorted. Then when again we will sort, we will get 35 is greater than, yeah. So here 35, let me use the color pen. Here we will get 35 and here we will get 3. We'll again swap because 35 is greater than 24. Here we get 35 and here we will get 24. We'll again swap and it will become 35 and this will become 35. So here we are getting one more extra element sorted. Means whenever we are iterating, the number of times we are iterating, we are getting that number of elements sorted of the array, and that too in the last part. So this is the basic technique of sorting, of using bubble sort. Now let's proceed to PPT and check out what's next. So here in the PPT also it's saying the swap the current index with the next. If the next index is smaller than the current, the last index and is not largest. Repeat it, repeating by iterating over the array and leaving the last sorted part of array. Means we are repeating and we will leave till the last sorted which we have done. So in the first iteration 45 was the last sorted, so we swap till this part only. This sorry. We do till this part only. We'll sort till this part. And when we will do the second iteration, then we can sort till this part only. So this continues, and I hope this is now messy again, but I hope the point is clear to you. So visual representation, let's move. And as you can see, we will compare first 3 and 44. When we will compare 3 and 44, this will be there will be no swapping. But when 44 and 38, there is swapping. 5 and 44 again, 44 and 47, no swapping. 47 and again 47 will be swapped, and again 47 will be swapped, and we will bring 47 to the end till it is a sorted one. We will not get 47 at the end, but we will get 50 at the end, as you will see. Now 47 50 there will be no swapping, but 50 and 48 they will be swapping. So this is how we will consider till the 48 index, and we will sort till only 48, because one sorting means we will get one sorted array, one largest element out of the remaining elements. This is the basic funda, and I hope you are able to visualize it using this tool. And if you are not able to understand, then when we will code it, you will be more clear about it. As you can see, we are again considering each adjacent elements and swapping as per our need. We will swap the largest element to the right part. Now I can increase the speed, as you can see now. I hope this is very much clear to you. And yeah, as you can see, this is now whole sorted array. Now let's move to next slide. Let's code. Okay. So as you can see, our array is there. We will first iterate over whole part of the array. Okay, a dot length a plus plus. Okay, this is what when we are iterating over the whole array. We have to iterate once over the whole array. Okay, this is for loop for that, and we will take a for loop till each iteration. Like if we have done first iteration, then we will take a dot length of the array. The formula will be, you will see how you will visualize it yourself only when I will write the formula. Length minus I minus 1. How? When I'm iterating, I have iterated I means 0 times. So it will move till length minus 1 till here. When I have done iteration 1, it will move till here. Then I have done 2, then it will move here. And it will go till I becomes length minus 1. When I becomes length minus 1, it will iterate till here. And when this will iterate till here, we will get the same element only. So this is how we are doing. We will move from j is lesser than a dot length minus 1 minus I j plus plus. And if our adjacent element is greater than the next adjacent element, then we will swap. And how we will swap? We will make a temporary variable aj. Aj will become ai j plus 1, and aj plus 1 will become temp. And this is all logic. And if you're not getting this one line, let me tell you what is this. Like suppose I have to swap 34 and 67. They are at a different memory locations. How will I swap? I will store 34 somewhere, right? And in place of this location, I will store 67. I will store 67. So I will put 67 here, and I will make this location equal to the other location which I have taken. So I will same to same copy it. So this is how we are swapping. This is the logic behind swapping. And I hope this is now clear. Now we can print our array. Now let's see our result. Our here result must be 3, 5, and then 24, then 35, then 45. Let's check if our correct answer is there or not. Yeah, as you can see, this is sorted. So this is all about bubble sort. And yeah, so we have coded. Now let's analyze the time complexity and how best cases we go of n. Let's take, as you can see, how we are computing this for loop will take n time. Okay, and this will iterate till n minus I minus 1, right? This current for loop. So whole will iterate, sorry, not whole, this part. This part one time will iterate this time, but if n times, it will iterate n into n minus 1 minus 1. Okay, so what we will get, n square minus ni minus n. But we take highest in big O time complexity analysis. So here highest will be big O of n square. And if you are not getting why we have multiplied, let me take you here only. Like see, let me first copy this array. Okay, let me take you to the visual. As you have seen, when we have iterating one time, what we were doing, we were swapping. And how many times we have iterated? N times. But we are taking index from 0 to n times, right? So we are using complexity n square times double, sorry, exponent, sorry, n square times only. How? Okay, let me tell you. Like suppose first we have swapped till here whole array, then again we are swapping. How much times we will swap? Until this largest element are coming n times. N largest elements will be there. So we are iterating n times by getting n largest element. So that's why it's n square. I hope now it is clear. And the worst case, when will the worst case? When there will be no swapping carried out. So only n will be there. So worst case time complexity, let me write it here only. Oh no. This will be worst, and I talked opposite one. Best case. Best case will be when there will be no swapping carried out. Only we will iterate, and that will be n. So this is all about time complexity analysis and space complexity. We go off one because we have not used any additional space complexity. We have only take variable temp for swapping and nothing else. So thank you, and this is all for this video.